Hello friends, we have an interesting problem today to solve, which is the integration of tangent q over square root of secant x dx. Before I do so, if you guys liked the solution, help me press the thumbs up icon below this video. The first step we are going to do is we are going to separate the tangent q into as follows, which is tangent x times tangent square x over the square root of secant x dx. After which we'll apply the trigonometry identity, the Pythagorean theory, that my tangent square x is equals to secant square x minus 1. So we substitute my tangent square x as secant square x minus 1. After which we can split the integral up into two integrals. The first integral will be the integral of tangent x secant square x over square root of secant x dx, and my second integral will be the integral of tangent x over square root of secant x dx. We will first work with the first integral, which is the integral of tangent x secant square x over square root of secant x dx. We use the technique called the integration by substitution. We let u be equals to secant x. So my du dx is equals to secant x tangent x, in which multiplying both sides by dx we get du is equals to secant x tangent x dx. My numerator can be expressed as secant x times secant x tangent x dx, in which if I were to apply the change of variables, I would get just u du. Over my denominator will be just square root of u. This is the same as the integral of u to the power half du. And I perform my integration, I will get u to the power 3 over 2 over 3 over 2, in which if I were to substitute my u as secant x, I will get secant x to the power 3 over 2 times 2/3, which means my first integral down here I will get is just 2 over 3 secant x to the power 3 over 2. Now let's focus on the second integral, which is the integral of tangent x over square root of secant x dx. We manipulate it in such a manner, we express tangent x as sin x over cosine x. Denominator, which is 1 over the square root of secant x, would just be 1 over the square root of cosine x dx, in which after I further simplify I will get the following, which is sin x over the square root of cosine x dx. Then I will apply the same technique, the integration by substitution. I will let u be equals to cosine x, in which when I differentiate u with respect to x, this gives me negative sin x. Multiplying both sides by dx, I get du is equals to negative sin x dx. I substitute my sin x as negative du, and my denominator will just be square root of u. So I get the negative of integral u to the power negative half du. I perform the integration, I will get negative u to the power half over half. Substituting u as cosine x, I will get just the final answer, which is the negative of cosine x to the power half over half plus c. Once we evaluate the two integrals, we can simplify the answer a little bit further. We have 2/3 secant x to the power 3 over 2 plus 2 cosine x to the power half plus c. Or we can just simply factorize the 2 out. We get 1/3 secant x to the power 3 over 2 plus cosine x to the power half plus c. This is the final answer to the integration of tangent cube x over square root of secant x dx. If you guys like this solution, you can press the thumbs up icon below this video and do consider to subscribe for more integration problems. I'm Bob. Thank you for your support and watching the video, and I will see you in the next video. Goodbye, guys.